And of course, how do we use or apply this in environmental planning? Wait lang guys, kasi hindi ko makita yung chat if ever. Um, is there a way on how I can? I'm making some technical assistance on this route. Is there a way that I can see the chat while I'm presenting? Ah, there. Okay, here you go. Okay, I can see it now. Sorry about that. All right. Okay, to continue. So for this one, for this lecture, I will be introducing a lot of terms. For the purpose of the exam, knowing them is our primary goal, but understanding them is secondary, but would be very, very beneficial because during the exam, you will encounter a lot of questions that are tricky. Um, like trick questions talaga siya kasi the possible answers, kasi iba multiple choice yun, so the possible answers might be two out of four of those um, options. So it would be better to know these terms and at the same time understand them. Pero most of the time naman, most of the questions, you really just need to memorize them or be familiar with them so that you'll be able to answer them. But there are really some that are trick questions that baka maka-encounter kayo, especially on the GIS part of the exam. Okay, all right. So what's GIS? Or GIS basically stands for Geographic Information System. But before we detail it down, we want to define first what's geographic information. So um, very easy. It's basically information about places on the Earth's surface. Okay, so and we are trying to uh, get some knowledge about the what, the is, the where, and the when. So always remember to do not forget time when you're interested on geographic information because um, a lot of our places would change over time. So AKA it's what you call like a temporal change. And on the other hand, we have these geographic information technologies, which is basically the technologies for dealing with this information. So these are some of the technologies that are available for us. So we have the global positioning systems, remote sensing, and geographic information systems. So yeah, now for this, ano ba yung GIS? No? So TLDR is that it's a system, that's the keyword for it, that creates, manages, analyzes, and maps all types of data. So being a system, it means that it has components, which we will be discussing in a while. And a GIS, or that system, it connects data to the map, which integrates the location data where things are, basically the science of where, and with all types of descriptive information, and basically what things are like there. So later on, you will see a lot of examples as to how we can display data using maps and how things have evolved, from early 2000s to like early 2010s and how GIS is being used right now. And there are a lot of very interesting use cases of how we're using GIS in our everyday lives. So this guy, see Dr. Roger F. Tomlinson, is the founder of GIS. And remember this guy because sometimes lumalabas siya sa exam. Um, he passed away in 2014, unfortunately, but he was the first person who coined the term GIS. And with that, this is how he defined GIS. Basically, it's the common ground between information processing and the many fields using spatial analysis techniques. So basically, what he's saying here is that you have these data and you crunch them using different technologies, and then it's also applied on multidisciplinary endeavors. So um, basically, that's what he was saying, and he coined it in 1970. So here are the four components of GIS. It seems being a system, as what I've said a while ago. And so first is that you have data input. So what data inputs are is that you have like raw data, and these raw data could be in the form of aerial photographs, it could be in the form of satellite images, it could be data also from existing maps. It could also be tabular data, even tables that you use on on putting them in an Excel file. You also have like field survey data and other data that could be from other digital databases. Um, there are actually like three factors that would influence your data input. So the first one is time. So sometimes it's really time consuming. Like for example, kailangan mo pumunta sa field at mag-gather ng data for say like not just like a week. Sometimes it could even take 30 days. Like for example, a very classic example of this would be yung mga nag-road count, yung mga nagma-manual count. Uh, like one engineer or one person, what one person would do is that they would go to a road and then they would manually count how many cars are passing by like every time so that they would have like a daily traffic uh data. So that would be time consuming. And actually approximately siguro mga 85% of GIS projects it's really more of data collection and input. And then the second one is cost. Yeah, getting data is costly. Um, like a lot of people wouldn't do it voluntarily, except if it's for their thesis, diba? And a lot of people are getting paid to get data, diba? And then the third factor would be the methods and the data quality. So our data quality would highly depend on how we input our data. So the second one is data storage. So it actually includes like two functions. And number one is that how do we store data into a GIS database and how do we retrieve data from the GIS database? So um, yung performance ng mga functions na to, it really depends on how the data are organized in the computer storage. So common practice in the environmental planning profession is that especially sa local governments, is that most of our data sets are stored in like a local computer or in a hard drive. And yeah, medyo advanced. We will talk about this also later, like the data maturity model, because there are some organizations that since they're processing or they need to process like gigabytes, terabytes, and even petabytes of data every single day, so that they could be able to utilize it. Yeah. So that's for the data storage. For data manipulation and analysis, this is actually where for me, yeah, the fun part comes in. And whenever you're going to do data manipulation, so you have like your tabular data. Oh, sorry. Hello. Um, is everyone clear from me? Am I clear from your end? So I think there's one chat menu clearing audio. Can somebody confirm on chat if you guys can hear me clearly? Oh, okay. Wait lang let me troubleshoot. Okay, sige. Wait lang. Sige. Baka yan, it might be in the mic, so wait lang guys. Let me troubleshoot lang. Can you give me 5 minutes? Hello, can you guys hear me now? Is this a lot better than before?
Yeah, it sounds better, Osh.
Okay, great. Okay. I used a different mic. Yeah. All right. Hello.
Osh.
Okay, okay. That's great. That's great. Okay. So, all right. So going back, oh yeah, so let's go back dun sa data manipulation and analysis. So, let me just share my screen again. All right, great. Hello, can you guys see it?
Yeah.
Okay, okay, great.
Thanks.
All right, thanks guys. Thank you for flagging that. Yeah, it happens once in a while. All right, so going back for data manipulation and analysis. So again, this is the exciting part because essentially you this is where you use your GIS software manipulating your data. So whatever you have, you put it on your computer and then you use a software or you use a programming language to manipulate your data so that you can extract insights from it.
And based on these insights, that's when you visualize your data. Okay. Yeah, so for data visualization, there are also tools that we use. So data visualization can also be in the form of like a static map, the one that you need to print sometimes on tarps or on papers or basically whatever paper where you need to print it. So yeah, that's how we visualize data. And sometimes you can also visualize it using geospatial dashboards. I will show some examples later. And yeah, so basically these are the four components of GIS being a system. So remember these four because they might be asked also in the exam. All right, so we are going to talk about GIS data and what are these. Okay, so there are actually two types of GIS data that you only need to remember. I remember this specific question. This specific question showed during my exam when I took it in 2014. So there are two types of GIS data. So the first one is vector, and the second one is raster. So for vector data, it's simply you have these vector, of course, but like vector files wherein they represent physical areas or like physical properties of the map that you're trying to represent. So it could be in the form of a point, or it could be in the form of a line, or it could be in the form of a polygon. And then on the other hand, raster data is basically anything that has pixels. So if you have like images that are composed of pixels, and then each pixel on that image, it contains data or it represents information about that area. Okay, so let's see if you guys know some examples of this. So we have a quiz. If you can give examples of these. So anyone can give an example of a point vector data. Basically, again, recap. It's representing something from Earth. So what are like places that they represent that can be represented by a point on Earth? Yeah. Okay. Good. Okay, correct. Yes, location of barangay halls, location of utilities, social facilities, landmarks, points of interests, critical point facilities. So yeah, that's correct. These are some examples of a point vector data. Um, so the next one is a line. So for road is better represented as a line. So which is also correct. It's also a vector data. Yes, so line for roads. What else aside from roads? Roads are very common. Bridges, correct. Rivers, drainage systems, waterways, water lines, pipelines. Okay, alam niyo na pala guys eh. Mukhang papasa kayo sa exam. But yeah, these are some of the things that can be represented by a line. And the third one is a polygon. So any example that can be represented by a polygon? Okay, boundaries, land areas, rice fields, watersheds, lake. Yes, correct. All right, great. So all of you guys are correct. So these are some of the areas that can be represented by a vector data. On the other hand, can you guys give an example of a raster data? Topography, yeah, okay. Accepted slope, yeah. Elevations, hazard maps, correct. Soil, yes, very good for DEM, digital elevation models. That's a good answer. Inundation depths, yeah. Okay, anything else? One last answer. Satellite, yes, very good. That's the answer that I was actually looking for. So satellite images it's actually a common raster data, and it's widely being used by a lot of organizations right now on GIS. So very good. All right. So these are some types of maps for data visualization na um fun fact lang. So parang kanina na share ni Ralph na lumabas to sa exam nila pero nakalimutan ko siya ilagay sa presentation ko. So I added it just like a last minute addition lang. But yeah, these are some of the types of maps are also being included in the exam. So one classic type is actually the thematic map. So That's why it's called thematic map, because it's representing a theme. So it has like a common, it's like a common theme. Usually, isang theme lang yung pinapakita niya. So for this one, like this example, this is a plant hardiness zone map. So ang theme niya is the plant hardiness. So meron, it could also be like a soil map. So it's also like a thematic map. Yeah, anything that has like, I think it could be a political map as well. So yeah. The second one is an analytical map. So in here, this is one of the maps that we made at Thinking Machines. So this is actually what you call a bivariate choropleth map. So I will type it for you guys. Bivariate choropleth. Okay. So why it's called bivariate and a choropleth is because number one, kaya siya bivariate because it's actually representing two variables, and then choropleth is basically it's represented in a gradient. But since it's bivariate, so we have like six colors here. So this map is actually um, a map that shows which areas would have would be wealthy and at the same time would have like high speeds of internet. So yung mga dark blue ones, so I don't know if you guys can see my pwede bang ano dito? Here you go. If you guys can see here, this dark blue color, so these are areas with or municipalities with low wealth but have slow speed and has also slow speed of internet. And then this ano ba to? Sky blue, tama ba? Basta this green one, it means that these are areas with they have like high internet speeds but with low wealth. And then these areas, ito naman, this color would have like high speed of internet and high wealth. So these are areas with basically wealthy areas. So if you can see like Metro Manila and some parts of like Region 4A, they represent these areas wherein they have like high internet speeds in the Philippines and also where where the wealthiest people are. So yeah, so this is a very good example of using analytical maps. We usually use choropleth maps, bivariate choropleth maps to give insights. And with this information, so what are we going to do about this? So for example, since we already know where areas have like low wealth and high speed, try to analyze as well as why do they have like what's like what's in those areas, why they have like high speed and low wealth. Maybe is it because like they have only a few population, and no one's really using internet that much, but at the grander scheme of things, they're poor. So yeah, these are some of the things that these are some of the insights that an analytical map can give to us. I'm gonna clear all of my drones. Okay. Another one is a topographic map. So a very classic one. I think a lot of you guys would know about this. So a topographic map is usually represented with contour lines. So if you can see here, you have this um, like irregular circles or lines. I don't know how to call this, but these are contour lines. Okay, so we call this contour lines, and it represents topography. So basically, it gives you information of how steep an area would be. So meaning kapag mas malapit yung lines with each other, it means na most likely mountainous yung area na yun at mas steep yun. Tapos kung magkakalayo yung contour lines, then most likely a lot of those areas there are on flat surface. Okay. And next is a road network map. So very classic example map also. You have this road networks where in Bohol, the red ones are represented as national roads and the blue ones are provincial roads and how they're interconnected with each other. So it gives you a good idea of where you can pass by if you need to go from one area to another. Okay. For the questions pala, you can type it, but we have like I believe we have like a 30-minute Q&A later after my presentation. Okay. So next that we're going to tackle on is the projections and coordinate systems. So, but before we proceed to that, I'll give you a fun fact that all maps are wrong. Maybe some of you would have raised their eyebrows by this time, but I'm going to show you a video from Vox and let me know if you can hear the sound. Okay.
All right, here we go. If I want to turn this globe into a flat map, I'm gonna have to cut it open. In order to get this globe to look anything close to a rectangle lying flat, I've had to cut it in several places. I've had to stretch it so that the countries are starting to look all wonky. And even still, it's almost impossible to get it to lay flat. And that right there is the eternal dilemma of map makers. The surface of a sphere cannot be represented as a plane without some form of distortion. That was mathematically proved by this guy a long time ago. Since around the 1500s, mathematicians have set about creating algorithms that would translate the globe into something flat. And to do this, they use a process called projection. Popular rectangular maps use a cylindrical projection. Imagine putting a theoretical cylinder over the globe and projecting each of the points of the sphere onto the cylinder surface. Unroll the cylinder and you have a flat rectangular map. But you could also project the globe onto other objects, and the math used by map makers to project the globe will affect the way the map looks once it's all flattened out. And here's the big problem. Every one of these projections comes with trade-offs in shape, distance, direction, and land area. Certain map projections can either be misleading or very helpful depending on what you're using them for. Here's an example. This map is called the Mercator projection. If you're American, you probably studied this map in school. It's also the projection that Google Maps uses. The Mercator projection is popular for a couple of reasons. First, it generally preserves the shape of countries. Brazil on the globe has the same shape as Brazil on the Mercator projection. But the original purpose of the Mercator projection was navigation. It preserves direction, which is a big deal if you're trying to navigate the ocean with only a compass. It was designed so that a line drawn between 2 points on the map would provide the exact angle to follow on a compass to travel between those 2 points. If we go back to the globe, you can see that this line is not the shortest route, but at least it provides a simple, reliable way to navigate across the ocean. Gerardus Mercator, who created the projection in the 16th century, was able to preserve direction by varying the distance between the latitude lines, and also making them straight, creating a grid of right angles. But that created some other problems. Where the Mercator fails is its representation of size. Look at the size of Africa as compared to Greenland. On the Mercator map, they look about the same size. But if you look at a globe for Greenland's true size, you'll see that it's way smaller than Africa. By a factor of 14, in fact. If we put a bunch of dots onto the globe that are all the same size, and then project that onto the Mercator map, we will end up with this. The circles retain their round shape, but are enlarged as they get closer to the poles. One modern critique of this is that the distortion perpetuates imperialist attitude of European domination over the southern hemisphere.
The Mercator projection has fostered European imperialist attitudes for centuries and created an ethnic bias against the Third World. Really?
So if you want to see a map that more accurately displays land area, you can use the Gall-Peters projection. This is called an equal area map. Look at Greenland and Africa now. The size comparison is accurate, much better than the Mercator. But it's obvious now that the country shapes are totally distorted. Here are those dots again so that we can see how the projection preserves area while totally distorting shape. Something happened in the late 60s that would change the whole purpose of mapping and the way that we think about projections. Satellites orbiting our planet started sending location and navigation data to little receiver units all around the world.
Today, orbiting satellites of the Navy Navigation Satellite System provide round-the-clock, ultra-precise position fixes from space to units everywhere in any kind of weather.
This global positioning system wiped out the need for paper maps as a means of navigating both the sea and the sky. Map projection choices became less about navigational imperatives and more about aesthetic, design, and presentation. The Mercator projection, that once vital tool of pre-GPS navigation, was shunned by cartographers who now saw it as misleading. But even still, most web mapping tools like Google Maps use the Mercator. This is because the Mercator's ability to preserve shape and angles makes close-up views of cities more accurate. A 90-degree left turn on the map is a 90-degree left turn on the street that you're driving down. The distortion is minimal when you're close up. But on a world map scale, cartographers rarely use the Mercator. Most modern cartographers have settled on a variety of non-rectangular projections that split the difference between distorting either size or shape. In 1998, the National Geographic Society adopted the Winkle triple projection because of its pleasant balance between size and shape accuracy. But the fact remains that there's no right projection. Cartographers and mathematicians have created a huge library of available projections, each with a new perspective on the planet, and each useful for a different task. The best way to see the Earth is to look at a globe. But as long as we use flat maps, we'll have to deal with the trade-offs of projections. And just remember, there's no right answer. If you
All right. So I hope you learned something from that video. So TLDR, but okay, so can someone explain what the video said to us why all maps are wrong? Um, at this point, maybe I might call a name. Okay. Huh. UP Plano, any suggestions whom you want me to call? So we would know if everyone's listening. Ralph, do you have any recommendations?
Hi, I would recommend si Jasper Hasildo.
Okay, Jasper, hi, are you there?
Hello. Meron na, ay, dito naman po. Pero, hindi po ba, bother yung background ko?
No. My question lang is that if you watch the video, can you explain like why all maps are wrong?
Kasi po yung projections are not at all accurate. And even though if we do keep trying, parang there's still that margin of error.
Okay, yeah, that's correct. So basically, TLDR is that we have this concept called projections, wherein it's whenever you're going to represent a 3D object to a flat object, there will always be trade-offs. No? So the projections that were showed kanina from the video of Box is that if you're using a projection such as the Mercator, ang trade-offs niya ay yung sizes, no, or yeah, the areas that are being represented by places, especially those that are in the northern and the southern hemisphere. So always remember that when you're dealing with GIS, projections are very, very important, and you have to use the right projection, and that would be very dependent on your use case. Okay. So yeah, that's correct. Projection from sphere to flat, and then from Bell, spherical trigonometry tells us conventional maps are wrong. Yeah, that's correct. Okay. Okay, and so yung nabanggit nga kanina is that the Mercator is the world's most common map projection. So it was also mentioned in the video kanina. So true or false? Google Maps uses the Mercator projection. You can answer in the chat. All right, that's correct. It was also mentioned in the video that Google Maps uses the Mercator projection. But my next question is why. It was also mentioned in the video kanina. Sige, maybe I can call on Cristel San Antonio. Are you there?
Hello. Okay ba
Hi.
yung...
Yeah. Yeah, I can hear you loud and clear.
Okay. Mercator siya para ma-preserve daw yung shape.
Okay. Yeah.
Like yung sinabi sa video was yung roads daw, mas na-represent niya. And since madalas naman nagzo-zoom in, so okay lang siya.
Okay, yeah, that's the correct answer. Okay, so great. They're using the Mercator projection for direction purposes, so that you can preserve the direction of or the usage usage of direction of the Mercator projection. So yeah, I hope you learned something from the video, especially for those who are new to the GIS discipline. Yeah, para one direction lang. Yeah. Yeah, true, because more accurate ang zoomed in maps with regards to the perpendicular. That's correct. Thank you, Belle. Yeah. All right. So, punta naman tayo sa, so we have this projection. So, we have also this like coordinate system. So, basically a coordinate system, it's again a system that uses one or more numbers or coordinates to uniquely determine the position of the points or other geometric elements on a manifold, such as the Euclidean space. Okay. So, in GIS, there are two types of coordinate systems that we use. So the first one is the geographic coordinate system, and the second one is the projected coordinate system. So para hindi kayo ma-overwhelm, yung projected coordinate system or yung PCS, as in it represents like the X and Y of your map. And then the geographic coordinate system, it represents this as a sphere. So like sometimes ang unit niya ay in degrees. Kaya if you see like measurements that are in degrees, so most likely it's the geographic coordinate system that they're using. And then the PCS would have like the X and Y of your map. So ganun lang siya. As in, no need to overthink for now because you might have a lot of questions. If you're going to use a GIS software like ArcGIS, you might encounter these two terms, but for the purpose of the exam, these are the differences of these two coordinate systems. So TLDR, a GCS defines where the data is located on the Earth's surface, and a PCS tells the data how to draw on a flat surface, kaya siya X and Y, like on a paper map or a computer screen. So we have a famous coordinate system that we're using, which is the World Geodetic System of 1984. So a lot of mapping technologies, they use this again kasi it's heavily based on the Mercator projection. So yeah, and I think Google Maps is also using this. So kapag kunwari if it's your first time to make a map using a software, naka-default siya to the World Geodetic System of 1984. Yeah, so try to remember this. This is the basta ang keyword niya is WGS84. So pag may nakita kayong ganun, it's the World Geodetic System of 1984. Okay, so we have another quiz. So what Philippine government agency is responsible for providing the public with map making services, or aka it's the Central Mapping Agency of the Philippines? Hindi ba DENR? In a joke lang, yeah. It's NAMRIA. So yes, you're correct, guys. It's NAMRIA. So for those who don't know, so NAMRIA is the National Mapping and Resource Information Authority, and it's actually an attached agency of the Department of Environment and Natural Resources. So yeah, they provide lots of mapping services. Is anybody here from NAMRIA? Baka we have like examinees here from NAMRIA. Wala. Yeah, but if just in case, so if you need like public maps, thematic maps, they have very rich information, very rich data sets of Philippine maps, and they continue to produce maps for the government and for the public. You can also even purchase like thematic maps from them. Yeah, so if you need any mapping concerns, feel free to contact NAMRIA if ever. Oops, sorry. Right. So with that, the reason why I introduced to you guys muna yung World Geodetic System tsaka yung NAMRIA. So here in the Philippines, we're using actually a reference system or a coordinate system, and it's called the Philippine Reference System of 1992. So there's actually a department administrative order, if I'm not mistaken. It's a DAO from DNR that maps that they highly encourage government agencies who do maps to use the Philippine reference system, because the reason for this is because it's not a global projection, it's specialized and it's more customized for Philippines, and they're primarily used for surveying political boundaries. So the beauty of this is that this system is already integrated on on like ArcGIS and even on QGIS. So if you're using these softwares, you can easily just use them for your projections. So these are the five PCS or projected coordinate system zones that that the PRS 92 is using. So you have like 5 zones, and so depende sa area mo. For example, if you're located in Metro Manila, then you use PRS 92 Zone 3 whenever you're going to create maps or to analyze or get measurements using your data if you're in Manila. Or if rather, if your area of interest is Manila. All right? Okay. So yeah, so these are some of the basic terms or stuff that we've encountered for the projections and coordinate systems. So now we proceed to what are the advancements in GIS. No, so a lot of things have already evolved from the time that when during my time, what we would do is that we would still have or we would still use yung version 3.2 ng ArcView ng ArcGIS, and I remember I was making a map that was really really hard to digitize kasi hindi the user experience is not really that great back then, but a lot of improvements were already applied with the current technology right now. So so before S3, the company behind ArcGIS, so dati very proprietary yung technology. So if you need to make maps, you need to contract them or you need to purchase the software from them. And my God, guys, ang mahal ng license ng S3 before. Pero ang alam ko, meron sila ngayon na parang, I think for just 1 year, $100, and that's only for like a personal or like a student license use. But the enterprise one is really expensive, as in like hundreds of thousands of pesos or even millions yata, if I remember correctly. So, but now, a lot of open source developers, they've actually developed software that can help those who do not have the budget to make maps of their own. So we have QGIS. Sige, I can type oops, wait lang. QGIS. So I encourage everyone to advocate the use of open source because it benefits not just us but everyone else in the community, in the GIS community. So a lot of developers are improving the QGIS platform, improving the plugins that come with it, and a lot of people are also getting access and how they would be able to understand their areas whenever by just mapping them. Diba? So yeah. And before also, a lot of the datasets are on-prem, meaning datasets that are hosted on the hard drive of like one GIS specialist in this local government unit. Wala masyadong access yung ibang departments, no? So on-prem, so basically that's it. You have your on-prem server. But now, a lot of organizations are actually using cloud platforms. We have like yung mga Amazon Web Services, Google Cloud Platforms, or Microsoft Azure, wherein these cloud platforms can definitely help on not just storing large amounts of data, but also crunching them, processing them, petabytes, terabytes of data every single day. And hindi lang siya just for storage and processing. The advantage of using cloud platforms is that the speed of the processing. So kung naka-on-premise ka, that would take you, say for example, rendering a map or like processing a map or processing a function in just 2 hours, like in cloud platforms, you can do it even in less than a minute or even like 10 seconds. Yeah. So that's the benefit of using cloud platforms. So before also a lot of the maps are being printed. Like whenever you go to an LGU or to a government office, that's the first thing that you see in in an office, and then it's printed in like a very big tarpaulin. Yeah, so before there are a lot of people are using printable maps, but right now a lot of the advancements are heavily using web and mobile maps. So we have like Google Maps and some maps that are customized by a lot of organizations, wherein they're also put in a dashboard so that it could provide us better insights. And it also could give us better information about these areas. And again, before we use small data sets, like we could only use kilobytes or like a few megabytes of data. But right now, a lot of GIS data sets are heavily relying on like gigabytes or sometimes even terabytes of data. Fun fact, there was one time that I encountered in my office na I had to do a spatial join of of Malaysia's land use map, and that whole file was actually like 3 terabytes. So imagine processing it, and if you need to extract something from it. So good thing that we're using a cloud platform. That's why we're able to do it easily. So yeah. And also before, a lot of GIS applications, they heavily rely on profiling. But I think the overall direction is that since we're already in the artificial intelligence era of the world, so a lot of the applications would be on AI and ML applications or machine learning. Hindi Mobile Legends, guys. Okay. So yeah, predictive analytics. How do we better understand the behavior of our world, and by using algorithms. So yeah, these are some of the advancements in GIS that's currently happening right now, and I think for the next 10 years it would still be prevalent. Okay. All right. So if you're from an organization who wants to beef up their data utilization and how you can process data, you need to consider, or you need to assess first where you are right now in the data maturity model. So these are the 5 steps. So you have, if you're in that stage now, the first stage is that if you're still not that mature yet, so you still do manual reports, you do spreadsheets, PowerPoints, and this you have disagreements on how data will be processed. Okay, so that's like the first stage, and up to the 5th stage where you can where an organization is already using AI and ML, wherein businesses are already using extensive dashboards, and employees are focused on high value work, and all low value work are automated. Yeah, so that's also a fun part of using geospatial data science, wherein you can also automate a lot of workflows. And sometimes we have new business models would emerge on these things, and how you can, and if you're from like an LGU or from a national organization, you would be able to identify which areas you can improve on, because of the insights that we are pulling from our AI and machine learning models. Okay, so so I think this is the last part of my presentation. So I will show you some applications of how GIS is being used in environmental planning. So of course, as a lot of people know, or as a lot of environmental planners know, we heavily use it in land use plans. So this is like an example of vegetation map in Bohol. So we use this to identify which areas how land is being utilized in a given area. Okay, so you have here like I believe that the that the Department of DHSUD. Oh my God, I'm so sorry. Please don't cancel me kasi sanay pa rin ako sa HLURB. But yeah, but the Department of Human Settlements and Urban Development is using like a color code for these areas. So meron silang cookbooks, like a GIS cookbook that you can download it from the website. So that, for example, if an area is commercial, you just you just put it as red, and if like an area is like forest, you tag it as a dark green. So yeah, so that it would be easier for anyone who would read your maps, na ma-identify nila kung saan ginagamit yung land. GIS was also heavily used to understand COVID-19 better. So during the time that COVID was on its early days, like so maybe you've seen this map everywhere on Facebook, on social media. So this is a map from Johns Hopkins University. They used ArcGIS to create this dashboard. So this is an example of a dashboard. Personally, I really like using dashboards, especially for I like creating them and giving them to our clients because they would it would help them better understand what their area is about. So for this one, at least the you would know like in just one instant look that the big circles are areas with lots of COVID-19 cases, and like the small circles are those with fewer COVID-19 cases. So always remember, guys, that humans are they're like visual beings. We are visual beings, so it really helps whenever we show visual aids, whenever we show interaction or like interactivity on this visual aid, so that it helps us humans to understand what our data is telling us. So it's not enough that you put it on tables. It's always best that you put it on charts, you put it on maps, and you put so that it would be better understandable for us, diba? Or sa mga managers nyo, sa mga bosses niyo in your offices. Okay? So, but for this one, this is how they use COVID-19. How they use map for COVID-19. For this one, I will be showing you some articles, some stories that we made at Thinking Machines. So these are just some of the work that we did. These are just three, and this TLDR basically GIS has a lot of impact when used with big data and AI. So I can wait. Let me just stop sharing and maybe show you some of the articles that we've made. Hmm. Okay. All right. So if you guys can see my screen, yeah, can you guys see my screen? That's my first question. Please acknowledge if ever. Okay, great. Yeah, so this one, it's a blog post that we made in 2018 with David Garcia. If you guys know him, he is map maker. He's a geographer and cartographer, a Filipino geographer and cartographer who became also one of the presidents of UP Plano before. And yeah, so we made a map before, wherein you can see here if your area has like at risk of like from natural hazards. And if you can see here, it's in a dashboard. So if you hover your mouse on like on these areas, so it will give you like the risk score, and the color represents, if the darker the color, so the risk is higher when you live there. Okay, so this is the risk score. So you can switch to landslide, you can switch to earthquake, to flood, to tsunami, to typhoon. And here we have identified that more than half of Filipinos are exposed to typhoons. So if you can see here, feel free to read it during your free time. So this is basically what we're doing at Thinking Machines. And this one, I also like this this scatter plot. So what this dashboard is telling us is that the smaller the circle, the smaller the population, and the larger the circle, the larger the population. The larger the population. And then in also here, we've also used colors to represent something. So kapag mas green yung color, mas low yung likelihood na matamaan ka ng natural disaster. And the highest likelihood would be those with with orange circles. So if you can see here, like NCR, what NCR is telling us that it's very susceptible to flooding. So for Quezon City, like it has a high likelihood and it has a larger population amongst other areas in the Philippines. So yeah, and we categorize it also into different natural disaster. Yeah, so basically this is how data visualization is effective for users. It's not really just enough for us to put it on a table, because sometimes it won't tell us anything. So if we put it in a tool like this, it would be more understandable. It would be more useful for decision makers. Okay, so this is the first one. And then the second one would be okay. So okay, let me share my screen again. All right, so can you see it? Um, okay. So the second one is that we were able to create a machine learning model that can estimate poverty and wealth in the Philippines. We've presented it at the NURIP's Machine Learning for Development Conference in 2020. And yeah, we're very happy that we're able to develop a model that generates low cost, reliable, and granular poverty estimates at scale in under a minute. By the way, this method it will never replace what well, you know what other organizations are doing when we're in they do like poverty estimates on the ground. But for this one, if the reason why we did this is because we partnered with UNDP and Zero Extreme Poverty Philippines. So we partnered with them so to create a tool that can help them identify areas instantly to assist them, to give them assistance for humanitarian aid. So you can read more about this in our blog. But the advantage of this of our work is that the cost is significantly cheaper, of course, than a survey. Um, um, we were able to create a machine learning model that can run in just like less than 5 minutes and then give poverty estimates or wealth estimates all over the Philippines in if in an 18 square kilometer grid. Yeah. So um so your next question might be is that how are we able to create a machine learning model? What data did we use? So these are some of the data sets that we use. So the first ones that we use Google Earth Engine. We use satellite images from Google Earth Engine, and we use points of interest, and we use Facebook marketing API data. So basically, gumamit kami ng data sets that would somehow infer that an area is rich or poor based on these data sets. Like for example, kung malapit kung malapit ako sa isang bangko, then the higher likelihood of me being rich would be a bit higher. And if, for example, if I have access to 4G, then most likely I might also be richer than other people. Also for Google Earth, we've also used like nighttime lights. So if an area is more luminous, then it means there's more economic activity there. Then yeah, so most likely mas mayaman yung area na yun. Okay? So um so when we compared it with the actual wealth data that was produced by in the 2017 demographic and health survey, so we were able to estimate it at almost exactly the same parameters and the same results. So yeah, we were able to interpret it also. If we want to interpret it on a per grade basis, we can do so. And so yeah, this is actually like my first paper with thinking machines, research paper, and yeah, we're very happy to publish this in Europe's. All right, so I'm gonna stop sharing here, and then the third one that I'm going to show you is one of our favorites. Um, okay, so okay, wait, let me share my screen again. Where is that? Where is that? Oops. Poverty. Oops, nawala. Give me a second. Okay, there you go. All right. So in 2020, we helped a Colombian NGO called IMAP to map informal settlements for humanitarian aid through artificial intelligence and machine learning. And so, like, if you're familiar with the Venezuelan crisis, the Colombian Venezuelan crisis, that's the rationale behind this. So what happens there is that so since nagkaroon ng economic crash ang Venezuela, what they're doing is that nagmamigrate sila to Colombia. So when they're migrating, it means that a lot of informal settlements are sprouting every single day. So ngayon, so IMAP, the NGO from Colombia, they came to us and then they wanted to know which areas if which areas would these informal settlements are sprouting. So we were able to roll it out, and we were able to detect more than 350 new informal settlements in 68 municipalities in just 1 month. So that IMAP would be able to give humanitarian efforts on the ground. So I'm not involved in this project, so I can't share the specifics. But TLDR, that's basically how GIS is used right now when we fuse it with big data, artificial intelligence, so that it would help organizations like IMAP make better decisions. So if you want to check the technicalities of this study, feel free to read it on our blog post. And so yeah, okay. Wait, let me reshare my screen again. All right, can you see it? All right. All right. So again, if you're interested to learn more about our work at Thinking Machines, so you can check out Stories the Thinking Machines. And yeah, so with that, thank you very much for having me, UP Plano. Do you have any questions? Yeah, I think the floor is now open for questions.